Hello everyone, today we're going to be working on problem 3.5, and this problem is saying that the members of a truss are connected to the gusset plate and that the forces are concurrent at point O, which is right here, and that we should take theta right here to equal 90 degrees, and T sub 1 is given to us to be 7.5 kilonewtons. So with the things that were given to us, it asks us to determine the magnitude of F for equilibrium, so this force right here, and to also determine the magnitude of T sub 2 also for equilibrium. So the first thing that I like doing is I like drawing out a free body diagram of the figure that was given to us, and I already drew one. So now that we have our free body diagram, so here we have our x-axis, our y-axis, we have T sub 1 right here, which remember is 7.5 kilonewtons. We have our force coming right here, and remember it is given to us that this is a 3, 4, 5 triangle right here, that theta is 90 degrees and T of 2. So the first thing that we're gonna do is we're gonna separate this angle right here in half into two angles. So what we're gonna do is we're gonna separate it right along the x-axis. So we're gonna have this angle right here and this angle right here. So we're gonna call this top angle right here, that's a bit too big. We're gonna call this angle right here, we're gonna call that phi. And we're going to call this bottom angle right here beta. So to find phi and beta, we know that the sum of both of them has to equal 90 degrees. And if we take a look at the force of F right here, we know that this is a 3, 4, 5 triangle. So if we were to draw it into a bigger triangle like this, and then complete it off with the x-axis right here, we know that this side is 3, this side is 4, and well, this side is 5, right? So by knowing that, to find this angle right here, we could use any of these angles, so any of these sides. So I'm going to use the side of 3 and the side of 4. And remember, we're trying to find this angle right here. So with correspondence to this angle right here, we are going to be using the opposite side of that angle, and we're going to be using the adjacent side of that angle. So remember, tangent is opposite over adjacent. So what we're going to do is we're going to write tangent theta is equal to opposite over adjacent. So if we were to rewrite that out for theta, we know that theta is equal to the tangent inverse of opposite. The opposite side, remember, is given to us to be 3 and the adjacent side 4. And then all that we're going to do is we're simply going to plug that into your calculator. Make sure your calculator is in degrees and not in radians. And this is given to us that theta is equal to 36.9 degrees, but remember we call this angle right here phi. So phi is equal to 36.9 degrees. So now that we figure out phi and we know that the sum of phi and beta is 90 degrees, the next step is simply just saying that phi plus beta is equal to 90 degrees. We already know what phi is, so we have 36.9 degrees plus beta has to equal 90 degrees. So that means that beta comes out to being 53.1 degrees. So now we could come back here and we could write out the value of each angle. So remember, feet turned out to be 36.9 degrees and beta was 53.1 degrees. So now that we found that, the next step that we're going to be doing is we're going to remember that it says to determine the magnitude for f and t's of 2 so that they could be in equilibrium, which is why the next step is we're going to be using um, our equilibrium equations to be able to find the magnitude of both of them. So I'm going to start off with our x components. So we're going to move this more up here just to make space. So we're going to start off with our x components. So the sum of forces in the x direction have to equal 0 to be in equilibrium. So we're going to start off with t sub 1. So if we take a look at t sub 1, we could see that t sub 1 is completely vertical. There is no horizontal or x component to it, so we don't have to do anything to that. Now we have the force F. Um, we are trying to find the horizontal component to it, so we are trying to find the side of 4, but we're also trying to determine the magnitude of F, so which is the side of 5. So we're going to be using the side of 4 and 5. So what we're going to do, and remember that if we are looking for the x component, so anything going to the right is positive, anything going to the left is negative, and this is slightly, it's like slanted to the left, which is why it's going to be negative. So we have negative f times, actually, I'm sorry. Now that we are given the angle right here, instead of using the 3, 4, 5 triangle, we're going to be using the angle. So if we were to look at this on the bigger scale of the bigger triangle, we are trying to find this side of the triangle and for our x component, but we are also trying to find the force or the magnitude of this side of the triangle. So with correspondence to this angle, we are trying to find the adjacent side and the hypotenuse side. So adjacent and hypotenuse, that is cosine, since cosine is adjacent over hypotenuse, which is why we're going to write out negative f times cosine, negative f times cosine of 36.9 degrees. So now we're going to move on to our t's, t of 2. Our t of 2 is going to be positive since it is slanted to the right. And once again, we found this angle right here. So if we were to draw a triangle right here and take a look at this triangle right here, we are trying to find the horizontal component, which is this angle, this side right here. I'm sorry, this side. And we are trying to find also the magnitude of this side of the triangle. So with correspondence to this angle, this is once again the adjacent side, and this is the hypotenuse side. So once again, we could use cosine to find our magnitude. So we're going to do plus t of 2 times cosine of the 53.1 degrees. And remember that all has to equal 0. So if we were to plug that into our calculator, we would get so if we were to plug in cosine of 36.9 into our calculators, make sure that it's in degrees and not in radians. We would so that would be negative 0.8, negative 0.8f, because remember we said that it has to be negative, so that's a negative 0.8 f plus, and if we were to put input cosine of 53 into our calculator, we get plus 0.6 piece of 2 has to equal 0. So that's the most that we can simplify this equation into. So now that we have that, we are going to move on to our y components. So next we have that the sum of the forces in our y direction also have to be equal to 0 to be in equilibrium. So our first y component, our vertical component, is our t sub 1. Remember, our t sub 1 is completely vertical, so we don't have to do anything to it. And remember, anything going upwards is positive, anything going downwards is negative. So this is a positive 7.5 since it is going upwards. So we have 7.5 kilonewtons. And now we're going to take a look at F. We could see that F is going pointed downwards, so it's going to be negative. And once again, looking at the angle, I'm going to just erase this triangle. We're not really using that anymore. Once again, looking at this triangle right here, we are now transferring the vertical component of this triangle, so this side right here. And we are also transferring the hypotenuse side of that triangle. So this time we are looking at our opposite side of this triangle, the correspondence to this angle to the opposite side and the hypotenuse side. And remember that sine is opposite over hypotenuse, which is why we're going to be using sine. So remember, it is, since F is looking downwards, it is negative F times sine of 36.9 degrees. And then if we were to take a look at our t sub 2, once again, that is going downwards, so that's going to be negative. And this time we're once again trying to find this side of the triangle. And with correspondence to this angle, that is the opposite side of the angle. And we're also trying to find the hypotenuse side of that triangle. So once again, we could use sine. So once again, t sub 2 was looking downwards, so negative t sub 2 times sine of 53.1 degrees. And remember that all has to equal 0. So we have 7.5 kilonewtons minus. If we were to put sine of 36.9 into your calculator, we'd get 0.6 F minus. And if we were to put sine of 53.1 into your calculators, we'd get minus 0.8 of t sub 2 has to equal 0. Now what we're going to do is we're going to move our 7.5 to the other side. So we would get negative 0.6 of F minus 0.8 of T of 2 is equal to negative 7.5. So now that we simplified also our y equation completely, what we're going to do is now you're basically just going to solve this by using either systems of equation, or you could input it into your calculator, which is what I like doing to save us some time. But so basically you would have, so if we were to put those two equations together, you would get something like this. Negative 0.8 of F plus 0.6 piece of 2 has to equal 0, and then we have negative 0.6 F minus 0.8 So those are our two system of equations, our two equations that we found. And from there, I like inputting it into my calculator. The calculator that I use is the TI-36X Pro. So to work this calculator, the thing that you have to do is you have to turn it on and then press the second button, which should be on your top left. And then from there, select the button that says SYS-solve, so system of equations. So now we have our system solver. From there, I'm gonna select the 2 by 2 linear of equations, and you're just going to press enter, and then simply right there, what you're going to do is you're going to input the negative 0.8 into your x component, the positive 0.6 in your y component, and on the other side of the equal sign, you're just going to put 0, and then you're going to go down, and then for your next equation, you're going to input the negative 0.6 into your x part. You're going to put the negative 0.8 in your y part, and then on the other side of the equal sign, you're just going to put negative 7.5, and then you're just going to press solve. And once you press solve, that should give you that that f is equal to 4.50 kilonewtons, and T of 2 should equal 6 kilonewtons. And just like that, we were able to determine the magnitude of F and T sub 2 so that they could be in equilibrium. So once again, the steps that we took to be able to determine the magnitude of F and T sub 2 is first step, draw your free body diagram of the figure that is given to you. From there, we were given theta, but to help us in the future, what we did is we solved for this angle and then this angle. We solved it by using what was given to us, that this side right here is a 3, 4, 5 triangle. So if we were to draw that triangle bigger, we know that this side is 3, this side is 4, and this side is 5. And we will use the side 3 and 4, so with correspondence to this angle, opposite and adjacent side, and we know that tangent is equal to opposite over adjacent, which is why we did this, and by using the tangent formula, we were able to find out that phi is equal to 36.9. From there, we know that theta is the sum of phi plus beta, so all we did is we subtracted 36.9 to the 90 degrees. So that's how we found beta. And then after finding those two angles, from there we just use the equilibrium equations, because remember it says to determine the magnitudes of F and T sub 2 for equilibrium. From there we simplified it to the most that we could, both of the equations. From there we just solved those for those equations, and we solved it by using a calculator, and just like that we were able to determine the magnitude of F and T's of 2.